Hello, my name is Peter Kim, and this is my Lab 1 Constant Velocity Lab Report for Physics 2211. The contents regarding this lab will be lab introductions, fundamental physics concepts you'll need to know before the lab, 3. Procedures, 4. Data analysis, as well as lab conclusions, and 6. Possible errors that may occur, as well as discussions at the end. The main lab objective was to compare an object's position as it travels at a constant velocity with a predicted computational model. Basic lab info that came with the objective is the object that rolling will be a tennis ball. Tools that will be used are Tracker, Google Sheets, and GlowScript to create the computational model. 3 fundamental physics concepts is the Newton's first law, or an object will stay in motion or stay still unless an external force interferes. 2. Newton's second law, or F equals ma, as well as momentum. Net force is equal to the change in momentum of the system divided by the time. F net equals delta P over delta T is one of the main formulas that we will be using in this lab. Net force. In this lab, the tennis ball has no acceleration or a net force of equaling to 0, which also means constant velocity. There are 5 main procedures or steps in this lab. Step 1 is to record the video of the tennis ball rolling in a straight line next to a meter stick. Step 2 is to import the video onto the tracker application, as well as set up a frame by frame to see the observed positions of the ball on the x-axis. 3. Use GlowScript to create a computational model of the ball's predicted position with the use of starter code and modifying it with the given information from Step 2. Step 4. Using the x position as well as the time graph, import it to Google Sheets to create a graph for the computational model. Goal: compare both models to create a final conclusion. The observed position of using the tracker application as shown on the screen. The total time it took was 0.384 seconds of the ball to roll. Initial position was the 0.00111357 meters on the x and 00 on the y and z. The initial velocity is 1.11593, which was given by calculating from the initial position as well as 0.017 positions after, and to find the initial velocity, or meters per second. The computational model was GlowScript. My code was modifying the original script where we changed the ball's velocity initial was to 1.11593 meters per second from the earlier slide, as well as changing the t from 2 to 0.384 seconds. Here, we are to apply the velocity update and position update formula, which are the 2 other main formulas used for this lab. What came next was the generated computational model as a predicted graph, as well as observed. Observed graph is shown on the left with the blue. Predicted is shown on the right with the red, or the computational model from the GlowScript application. Here are the both graphs come together with the blue being observed and position being the red. It shows how very little difference between the both lines have, and they're actually very similar to one another, with minor discrepancies. Now, some possible errors that may have occurred from the lab. 1. Outside forces such as friction as well as air resistance may impact the system. 2. Position tracking. While using the tracker application, errors while placing the center of mass and the tracker may cause some discrepancies. 3. The rounding error. Results may not be precise down to each decimal, as we must round values, leading to small differences in our answers. Further questions. What if plus and minus x were interchanged? Not many issues would occur, but the only difference that would occur are that the slope of the graph would be negative. 2. Is our net force equal to 0? What forces are being added then? We are unable to tell. We can state that the gravity and normal force are forces acting on our system, but there are also maybe air resistance as well as friction that may result to a net force not being 0. Thank you.